morning to all. Come to Mr. Thilina. Thilina is so long before he go to Norway. I think he was one of our previous visiting lecture for the BSc cybersecurity. So with advanced networking, Thilina was one of the key lecturer who was played a huge role in lecturing, and Thilina was one of the major contributor to the network industry in Sri Lanka, and he worked for the Learn, so the research network. That's a government network project, and he guided most of the network. Thilina can give his research in 5G. That's a total new technology that he's working around, and he is one of the previous Internet Society member in Sri Lanka. Currently, is the Lanka Network Operators Group, the group where all the computers, all the ISPs part, and to develop the internet of the Sri Lankan ISPs. And this will going on. I'll give to the Thilina. So Thilina will give you more, and you can ask questions during the question sessions, and he will brief you in details about all his work and what currently doing. And meantime, you can give you in and out about the containerization. He will give you from the introduction to, as we mentioned, of all the 5 topics. Thilina, I believe, much eagerly waiting to know about what is containerizations, because better to start from the container itself, then it will be very good.
Yeah, thanks. Yeah. So, okay, let me share my screen first. All right, so with my audio, please let me know. I'll switch off my camera because there might be some disturbances time to time. Okay, so hope I'm audible correctly. And I'm Thilina Pathirana, as introduced by Sia. And currently I'm a PhD student, let's say that like it, and in one of the universities in Norway. And one of my research areas are like finding security related to these containers that are related to newer network fields, which I might introduce you later. So today I'll be introducing some of the concepts behind what we call as containers. They are not the containers that you see on the road, but something similar but digital. Basically created for a master course that I was teaching in the University of Stavanger, where I do my PhD. I have reduced some content, but there are a lot of content. Let's see how we can cope with the timing and the content. So these slides, I have an acknowledgement to a colleague because that person helped me to create these slides. Okay, so before going into containers directly, we should talk about the virtualization and the infrastructure that you will find in the cloud. I'm not going to go into details of the cloud infrastructure, but I will just do a few slides, and then I will go through virtualization, because you need to know virtualization before going into the containerization. And then we will talk about containers, and then the difference between what we call virtualization and what we call containers. Then we can talk about some security best practices, business opportunities, kind of stuff. Okay, so what do you think of cloud infrastructure? When someone says about cloud, what are these? There were some memes around internet. A small kid asking his father what is cloud made of. So that father answering cloud is made with Linux servers. So that is another example. So basically, when you go with cloud infrastructure gets its hardware and the virtualization, different levels of storages, and a very big and complex network. So these are some of the things that we have in the cloud. And when you go into the hardware resources, like on a cloud, there will be different physical hardware, like multiple locations around the world. So you might not really know what physical hardware that you are connected or where you are getting connected unless you really specify where that was. The same with every other hardware device. So when you talk about hardware, it's not just the server or not just the that chassis, but it includes all the networking equipment, storages. So when you talk about storage, in cloud, storage is a different element, and it may be a part of the computing unit, computing device, but again, it might be a different entity, completely individual from the other hardware. So basically, you will find computing devices as hardware, which do all the CPU, GPU stuff. And then you will find the storage, and then you will find networking, mainly in cloud infrastructure. And then these can be a centrally controlled central element. So all these things will be centralized, even though they are like positioned all over the world. For you, it will be a central location, mostly virtually. So when we talk about the network infrastructures, there are like different levels of network infrastructures, network devices. Most of the time, cloud will concentrate on data centers, which will be located in different places. So these network data centers will have complex network topologies, complex networks, different types of networks, mainly fiber, if you consider the physical elements of the network, and with like large number of gigabits per second, for example, 100 Gbps or 100 Gbps throughput. Most of the servers will be connected with at least 10 Gbps cards or connectivities. So these are how a server or whatever other device that connects to the network will connect to its network. And there will be a lot of other devices within the network, not just the switches or routers, but there will be a lot of devices levels of firewall, controlling, load, many other things that will be in the for most of you, storage solutions might be something new, because most of the time, if you are using let's say a local server or even a PC, that your storage will be something inbuilt within that. But when you go into data centers, there will be different storage solutions, different types of storages, and then there will be different types of replications of these storages, because everything depends on your data. So they will keep backups, they will keep real-time replications or duplications of the data. So these things will have different methods of doing that, doing the storage type in kind of like block storages, object storages. Likewise, I'm not going to go into details of these things. One of the popular methods is this elastic storage, where you define some storage space for a service, but then depending on the demand, the size of the storage is kind of scalable. So that is what is called elastic. So those are different types of storages where you will find in the current cloud infrastructure. So that's kind of a quick and basic idea of what cloud is. So any questions on this? Then the virtualization component of a cloud. So most of the time, these cloud devices, even though these are different hardware devices, different physical devices, when it comes into services, all these hardware devices will be seen as a single hardware or single network or single storage. That is because these are things that are virtualized, and depending on the service, depending on the user, that user will see some isolated virtualized component. Let's say if it's hardware, it will be a virtualized hardware, and then if it's kind of like network or storage, it will be something completely virtualized. For example, if you want to buy 100 GB from Google Cloud or something, you will get 100 GB from Google, but you don't know where that is because it's completely virtualized. So what is your knowledge on virtualization? I know a lot of you might have been using different mechanisms to have virtual machines, maybe on your PC, maybe on some sort of a cloud service. But really, what is virtualization means? So sometimes back when we were like using different hardware devices for different services, we had, let's say if we had 3 web servers running on our company or wherever you work, we used to have 3 physical web servers separately for these 3 websites. That is because we wanted to keep everything isolated per website, and each website had its own hardware part, its own network part, its own storage part. But the drawback of this is like you are not using all the resources that you have when it goes into these 3 systems for this example. So because of that, you keep underutilizing your resources most of the time. For if it's just a website like WordPress or even a Moodle, most of the time your servers will be stay idle because your users will not be using all the resources that this particular server has. So that is where we go into the concept called virtualization, where you share resources with different services, so your resources are efficiently utilized. So what is the hardware components in a single computer? So these are called processors, memory, storage, and can be like many other things in a particular single computer. But when you go into virtual computers, what will you see? You will see virtual machines. So these virtual machines has become some sort of a common norm in the modern IT architecture. That is because these virtual machines, they are like kind of cost effective and scalable. It's just you contact your service provider or you create yourself a VM based on your need. So it's really scalable and it's really easy to increase resources. So these things had key benefits like the ones you are seeing in the screen. So these are the current benefits that you get from these cloud services, virtualized services. Okay, so before going into the containerization is another way of doing everything virtually. But for that, you need to have an idea of the virtualization. So currently there are like many types of virtualizations. In our case, we are like focusing on something called the server virtualization. That is where you will see containers. But apart from that, there are different other virtualizations for you. For someone that works at home, might use desktop virtualization where you have multiple VMs running on your some sort of software. Then most of you have used network virtualization, let's say VLAN, for example. Then storage. If you are using cloud storages, that is basically storage virtualization. And even if you are hosting a website somewhere on a cloud, that is basically hosted on a virtual storage. At the same time, there is something called the application virtualization, where there can be different applications that use methods of virtualizations to get the advantage of those. For example, let's say if you are an admin of Microsoft 365 for a number of people, let's say 10 users, that means you are virtually using Office 365 for your purpose, for your 10 users, but you are just using that application. You are not installing an instance of Office 365 for your own, but you are using Microsoft, whatever the Microsoft people have installed as a portal for you. So that is again some sort of virtualization for applications. Okay, so this is where you see the virtual machines. You have 3 layers of the device or the system. Let's say it like that, the system, the whole thing. So you have the host hardware, something called the hypervisor, and then the VMs or the virtual machines. And these virtual machines will have a small, let's say, a configuration file, which is called the VM configurations. So it is a basic idea where they define a file which have the resources, like this VM have this much CPU, this much storage, this much network, etc. So that is the basic idea of a VM. But when you think about the types of VMs, there can be different types of VMs. Like if you're a Mac or Windows user, you can have your VMs on that, as well as you can create Mac or Windows VMs. The same for Android. Most of the time we use VM for Linux on Windows or Mac, but again, there can be different other things. Like there are, if you are a programmer, you might have been using Java VMs or Python VMs. And then there are different types of, people know VMs with different types of commercial software names. So that is how people know what a VM is. But then the advantages are like resource utilization, scalability, portability, like flexibility, different types of security. So what or how this happens? So these VMs, they are not directly connected to a hardware. They don't have a particular dedicated hardware. So how these things work, how this virtualization work. So that is because of the hypervisor. This hypervisor helps this VM to connect with the host hardware and the software. So that hypervisor is basically a software. So this is the interface, and these hypervisors can run on top of your hardware or on top of OS. Then this virtualization or the VMs, they use this virtualization technology, and these hypervisors, they are also known as virtual machine monitors. So if you read some documents, if they are neutral documents, most of the time you will see the name VMM for the hypervisor, because these are like the standard name, rather than using a commercial or using some name. So you will see VMM as the hypervisor, and then these hypervisors are capable of assigning different resources for different VMs logically. Okay, so when you talk about the hypervisors, there are several types of hypervisors. First one is type 1 hypervisor, which you install the hypervisor on top of hardware directly. So you will get the hardware first, and then you install the hypervisor on top of that. So these type 1 hypervisors, because of they are directly installed on top of the hardware, they can control your resources directly, and these are hypervisors that can be used for a lot of, let's say, cloud infrastructure. So what do you know about type 1 hypervisors that associated with Linux? You can type, or you can even answer me directly. So Linux hypervisor is an example is KVM, but then there are different other hypervisors like from VMware you will see something called VSXi, and then again another example is something called Xen. Mostly everything is Linux based. Then the type 2 hypervisor. So the type 2 hypervisor is kind of something a little bit different from the previous one. Here now we will find a intermediate layer between your hypervisor and your hardware, which you call the host OS. So the hardware, you call it as your host, and then On top of that, you install some sort of operating system, let's say Ubuntu or Windows, and then you install your hypervisor on top of that. These type of hypervisors are mainly used with desktop devices. For example, if you want to install some sort of a hypervisor in your PC, then it will be a type 2 hypervisor. So what are those softwares? One example is Oracle VirtualBox. So our VirtualBox is basically a type 2 hypervisor. And then VMware Fusion, VMware Workstation, those are also type 2 hypervisors. Okay, so these hypervisors, they allow you to create VMs manually, install a guest OS. They are capable of giving resources with the permission of your host OS. And then these type 2 hypervisors, they have different issues like latencies, because if your host OS have issues, it will reflect on your hypervisor. Definitely performance issues will be there, and security risk. If your OS is a vulnerable OS, those security risks will affect your virtual machines as well. So this is an example of all these. So in the middle you will see the standard one, like the idea of the virtual machines. So basically the one on top of host hardware is called type 1, and type 2 is having something in between, which is called the host OS. So this is the difference of type 1 and type 2. So you need to know this before you get to go into details of what is containerization. Okay, a small comparison between VMs and bare metal servers. Bare metal means the physical servers without any virtualization. So they have, so the VMs are managed by hypervisor, bare metal directly with the hardware. And when there are virtual machines, it's easy to isolate environments, but with bare metal devices, you need to do different things. So it can be a challenging thing. Sharing resources versus dedicated resources, and then how flexible you are with provisioning and scaling your services. So those are two sides of the story. And then most of the time VMs are hardware independent and portable. That means you can get a copy of your VM and transfer it to a different device, different location without much changes. But when you install something on a bare metal, it's really a problem to change things from the hardware side, because they will be tied with all the hardware programming. When it comes into this security side, there are different advantages as well as different challenges. So if for example, isolation is an advantage, as well as something called snapshots, where you can create a copy of your VM. Those are advantages, but if someone attacks your hypervisor, that is a challenge. because of all of these things and some of the other drawbacks of VMs, there is this containers that is some sort of a next stage on top of the virtualization. So here again, containers use virtualization up to some point, but then it's not completely virtualization. So that's what container in one or two sentences. So let's go into deep and see how those things are. Okay, so what is a container? So with these containers, with the slides, we will be talking about what these containers are, how they change the way we are working, and then what are the different technologies that for different domains that we'll be talking, and that what they are getting advantaged. Okay, so most of the time these containers, they came up with different ideas from Google. They wanted to address different issues that VMs had, so they were trying some stuff with containerizations. That is where we get the word, at least. And then with the containers, there is no need of having the complete OS, complete operating system. For example, if it's a VM, you need to install a guest OS on top of the VM. Like if you need to get some work done from a VM, then you need to install the guest OS. But with containers, you don't need to install a complete OS because containers are not really using the whole libraries of OS. And then because of these things, they are really easy to launch as well as really easy to delete. So there are like portability, real fast portability, and as well as the migration. So it's really easy to migrate from one place to another with a container, and it will be real depending on your network speed and depending on the size of the container. It will be really smooth and really quick. For example, if it's some sort of a web server, it might take like few seconds to do the migration from one place to another place, depending on your network. Okay, so what is the container? Basically, a container means a package of software that connects with your operating system, uses your operating system's libraries or your operating system dependencies, but then creating a lightweight executable based on your settings for a particular application. If you want a web server container, it will be a executable software as which gives you a web server. If it's let's say some sort of accounting package, that accounting package container will have whatever the software that relates to the accounting package plus some dependencies, but then it will be a executable thing in your OS. The same goes with different other applications. So if it's a Python application, you will be running some Python codes with some Python libraries, but you can install that container even on a device that doesn't have Python at all. So that is something with the containers. Behind the scene, what it does, it uses your operating system dependencies or libraries to work whatever the application that need to be done. So because of this is really efficient and really portable. So you just create a container in one place, and then you can distribute those containers anywhere on any device. So because of these things, today most of the time cloud native applications, like if you want to install a quick service in one of those cloud providers, these cloud providers, they have containerized these applications. So when you click something for you, it will create a new application, new container for you, and then your services will be up and running on whatever the cloud platform. So for example, there can be a service provider who gives you instances of content management systems. For example, let's say WordPress. So if you want to create a WordPress, what it will do is it will create a container based on some pre-configurations and give you a newly installed WordPress instance, but then it will be a container from the backend. So the beauty of these containers are like, containers are written once and then they can be run anywhere. So that is the basic idea behind this. Okay, a container. So basically these are lightweight, maybe few megabytes up to several gigabytes depending on the application. And then they will have standardized dependencies, but they will have isolated apps from each other. So even you will get an attack on one application, it won't affect the other applications that are running on your other containers. And these containers today works on all the major distributions like Linux. Those are like basically working on Linux, even on Mac OS or Windows. So for example, if you create a WordPress container, you can run that container on your Linux machine. You can run the same container on your Mac OS, or you can run your WordPress on the same Windows machine. You don't have to install some web server or some other dependency for that. Okay, let's see how this happens. So these containerizations, what it does is, it is a kind of a bundle of the application, and this bundle contains all the configuration files, libraries, dependencies, but still a single package. So the best thing, unlike the way of doing traditionally, these containers, they don't have any dependency to your operating system. So you can run these containers on any operating system. So that happens due to something called runtime engines. So these runtime engines are the software that you install on a host OS, and then on top of that you run your container. So one of the common container runtimes are something called Docker. I hope most of you have maybe already using Docker, and most of you might have heard the word Docker. Okay, so the shared resources and efficiency of the containers are like they have common libraries and different configurations. So these are shared among most of the containers. And then in terms of capacity and starting time, uh, they don't need the full OS to run uh, the application. So because of that, they are more efficient. And the same thing, because of that, they have a small footprint. So your container is really small and fast startup, and it will give you a high server efficiency, like really fast. Then you get the same isolation like VMs, but now this is not a VM, this is a far smaller application. So these containers, they are also like isolated. So if you create several containers for several applications, all these applications will be isolated from each other, but still it depends on your code. If you have dependencies between the containers, then it will be dependable. And then the portability. So like I said earlier, you can, when you create the container, you can use that container wherever you want. Like it can be on a cloud, or it can be on your desktop, or in on top of a different VM, a different OS. So these are really portable, and you can simply move here and there, and then it will be like quick transfers between the different environments. Okay, so when I'm telling some words, if you don't understand the concept, please raise your hand or ask the question, because I will assume that you know some of the words when I'm explaining. Okay, so this is the basic idea of what you see as a VM and as a container. So for the in this example, like you see, so for this you have type 2 virtualization, where you have the host hardware and then a host OS, and then on top of that the hypervisor. So you see two VMs running, let's say the green VM and the red VM. So the green VM, it have kind of the whatever the guest OS, and then its own libraries, and then its application, let's say app 1 and app 2. So for the red VM, its own OS, own libraries, and the application too. So that is the way how you do with virtual machines. But when you create this app 1 and app 2 as containers, what it does is it has the host hardware as well as every other machines, and then the host OS, and after that you will have the container software or the container runtime. For example, let's say Docker. So this container software will have different containers, like the container software managed in different containers. So in this case, application 1 and application 2. But compared to the VM, you will not see a guest OS for the container, because it doesn't need the guest OS. It will only use whatever the dependencies with the library. So it will have a layer of libraries, but then the application. So this is where you get the lightweight. I think most of you have an idea that when you install an OS, it will be a bulky installation, like at least 5-6 GBs for a guest OS. But when you go into containers, you don't need that much space. Okay. Before going into LXCs, any questions from this? Okay. So no questions mean, did I explain it correctly, or none of you understood what I said? Okay. Then let's see what is something called LXC. So when the containers were getting popular, that happened because of something called this LXC. So when different developers wanted to explore this idea, the easiest way was using Linux as the playing ground and then come up with different solutions. So for that, people use containers which ran on that is called Linux. This Linux can like open source as well as Linux built-in functions with the Linux. So Linux OS had built-in container technology. So these containers, they are self features. You can use multiple applications on a single host. You can run 3 LXCs to run 3 different web servers. Okay. So this LXCs, even today you can easily use LXCs with any Linux operating system. For me, I was a fan of Ubuntu, so I really used LXCs on top of Ubuntu. So you just install Ubuntu on whatever the server and then run multiple LXCs. So the LXCs, they are like data intensive deployments, so they can be efficiently used to read and write large amounts of data. I even have tried different LXCs with Elasticsearch for like big data applications or big data analysis. So there are different LXCs you can use for these kind of things. So it's really easy. The best part of LXC is they still use Linux namespace, so all the Linux functions will be same within the container. You can use the same file structure. You can use the same, let's say, a process ID, a network ID, same as your Linux machine. So it will be really easy. Okay. Then the best part, what is the difference between virtualization and containerization? If I go back to the previous slide of that image, even from the image you see containers are lightweight compared to a virtual machine. But what are the other differences? So basically, both containers and virtual machines are used to run multiple software on the same environment. So even you use multiple VMs, you will be doing the same as you are running with multiple containers. Only thing is what running behind. So the container, they offer more benefits compared to virtualization. So that is why it is kind of now the preferred choice for a lot of IT people. But what are these additional benefits? So virtualization efficiency, they are like when virtualization run on different applications, different OSs, still they run on the same single physical computer. So these applications, they have dependencies on the package or in the VM, so it have a cost saving. When it goes into containers, they only have the application, whatever the container application, configuration and dependencies. But the difference when compared to a VM, container don't have the copy of the OS. It uses the host OS. So because of this, container runtime, they are sharing OS on all the systems. So because of this, what happens? You don't have to install a OS. Your hardware doesn't have to schedule things for different OSs inside your VM, inside your physical machine. Instead of that, containers will be using the same OS. So your hardware will be running on the same kernel. Okay, so this is a comparison type 1, type 2 and containers. There are ways of installing containers on top of any of these hypervisors. So where you install a VM and then you install your container applications on top of the VM. But then that means you are doing virtualization and then containerization on top of that. But this image doesn't show anything like that. This means purely type 1, purely type 2 and purely container, where you have your physical device, on top of it your OS and then the container engine. So this, for example, let's say this app 1, if it's on the hypervisor 1, type 1, it contains something like this. If it's type 2, it has the host OS. And then if it's the container, it will be something like that. So what is the difference? From the first glance, you will see container doesn't have guest OS. Because of that, container is little small than the other VMs. But if you see, here now we have the host operating system, not like something like type 1 hypervisor. So all the containers, they will be using the same OS, but then it doesn't have multiple OSs. So this is the advantage of having containers. It's lightweight, it will use the same kernel as the host OS, host device. Because of that, it's really easy to do stuff with containers. So, rough idea of VMs and containers. So the VMs, they have their own guest OS, but containers, they use the same kernel. Performance-wise, because of the guest OS, there will be a slight overhead, but the containers, they will have the native performance of the host OS. Security, VMs, they are completely isolated, but containers, they are isolated, but with the namespaces, because now it's running on top of the VM, top of the guest or host OS. So still you will be isolated, but you will have isolation based on the namespaces. Storage, definitely containers are much lesser than the virtual machine. Then the isolation. So the virtual machines, they basically have the high level of the isolation because they are completely different. Then containers, they are again isolated, but can be shared because they will be on a subdirectory on the same storage. When it goes to networking, for both of them, it will be mostly same, but with containers, they use the same applications of the OS, the host OS. Because of that, there might be some issues, but at the same time, there can be advanced features which a normal NIC won't allow you. For example, there are ways of connecting high-speed, high connectivity methods or virtual networking routing, SDN kind of things with the containers easily. Boot up time, basically virtual machine, they have the few minutes booting time because you need to boot up the host machine, the guest OS, and then for containers, it will be few seconds because it will be already running on top of the host OS. Then, security and best practices of these containers. So the containers, when you create a container, that is called an image. So like when you want to download the operating system, you download an image. Likewise, when you create a container, it is called an image. Try to use always these official images because, for example, if you want to run a web server, let's say Apache, try to use the official Apache container rather than using some random guy hosting on some GitHub page or somewhere. So best way is to use the official image. And then even you use an official image, try to keep these images up to date because most of the time these containers, they will be updated like every week at least. So you need to keep them updated to keep security patches up and running. Then if you have tools, then try to run different vulnerability checks, scanning on your images, or even you create a container, try to do these things. I'm not going to explain how you do it, but you can easily use LXCs, you can easily use Docker on any device. So it will be really easy to do the containerization of applications. And then best way is to create applications with minimal images. So when you take containers, for example, let's say you want to download the OS from some, let's say Windows 11 or Ubuntu latest, whatever the copy. When you go into the download page, you will be asked multiple questions, like whether you need this application, whether you need that application. Likewise, based on your requirement, they will give you a proper image. But have you ever selected the minimal image? So there will be a minimal image with whatever the important libraries or whatever the key parts. But then most of the time we go for the largest image. So sometimes there can be a 3 GB ISO file. Again, there can be a 6 GB ISO file. Most of the time we go for the 6 GB ISO file because it contains all the things. But when it goes to containers, don't do that. Even containers have multiple versions, like the minimal image or a heavy image with a lot of other files. So most of the time for security, the best is to go for the minimal image, because it is the place where you have the lowest risk. And then there are different isolation techniques. If you are really going to learn containers, furthermore, you will learn different technologies. So try to use these isolation techniques to do the security best practices. So that is the part where you get security to your containers. Okay. Then with the containers, you will need to give the least privileges. So even within network, if you are using IP tables, restrict container capabilities, because there can be loose ends where someone can manipulate your system. So try to keep the least privileges, network segmentations, secret management. Like if there are sensitive data, let's say password, even a password, try to encrypt them, or even try not to hard code them. Monitoring need to be done, like with implementation of logging, maybe even network monitoring as well. Then the host security. Wherever you run your container, make sure your host is secure than the other things, because physical security is also something that people need to think. If your container is running on a cloud environment, you need to keep proper API controls. Like even if you are using API, try to use the secure channels at least, and then keep backups as needed, because it can be a problem at some point. Then, what is the business benefit of this container technology? So today, people use physical devices, some uses virtual devices, and some use these containers. What is the difference? When you use hardware devices or physical devices, that is really expensive. So, and then if you are using virtual machines, it is comparatively cost effective, but does that have all the other functions that a container can give you? So these are some of the business benefits of a container. Like you have the real portability, you have the isolation, scalability. Most of the time people will consider portability and scalability because it is the thing when you need, when there are like heavy applications, especially the scalability. And then the things that people don't talk, that is the security and efficiency. So for a business, all these things need to be considered. Like it need to have proper security, need to have efficient way of running things. Okay, so that is what I have included into the basic idea of containers. I didn't go into ways of doing containers like the actual codes or anything, because that can be something really hard or really advanced. So this is just a basic idea of virtualization, cloud, and then the containers, and what is the difference of all these things. If you are just a student or even an early career person, my advice on containers is like, if you really like the DevOps part of the IT life cycles, try to do some sort of vendor certifications on containers. For example, AWS, they give the certifications, so that will be something that you might be looking at. Okay, so there was a question on how we can create a container. Yes, I didn't go into details of that because the easiest way of creating a container is like you downloading a container from a container store. So for that, if you are running AWS or some cloud provider, there can be their own methods of doing that. For an individual, the easiest way is to run Docker on your PC. So you install Docker and then you download whatever the container that you need to run. For example, installing Docker is really easy. You just go to Docker website and follow the installation instructions. That's really easy for any operating system. Then creating an image. Let's say if you want to run a web server, you can simply download the container image from the website, from the Docker website, and then run on your server. That's really easy. So running those containers are really easy. Any other questions?
Thilina, I have a question. Now, we focus mostly on Linux, Linux based for the containers. Can we do this in maybe Microsoft or anything, or is it only Linux based?
Sorry, I didn't hear the last part.
So, are we using only Linux for the these containers? Can we use Microsoft? Do we have any other facilities like any other OS, Microsoft or Apple or anything? Because all focus on Linux.
Yeah. Okay, let me share my browser first. Okay, so when you go to Docker website, you can like click get started and then download. For me, I'm running my MacBook, so you have it automatically shows Mac Apple chip, but then you can see Windows and Linux as well. So what you need to do is you can just download this app package and then run it. So it doesn't matter whether it's so this is the screenshot of the Docker hub where you download the different images. So yeah, it doesn't matter whether you run it on Windows machine or on a Mac machine or on a Linux machine. I use Linux for the example, but whatever the application that you run, it can be anything. So it doesn't matter really. There was a question about Kubernetes. Okay, so I didn't go into Kubernetes at all because Kubernetes is something else from containers. Kubernetes is something that used to manage containers. So Kubernetes will do the management part of containers and the orchestration part of containers, which is something far more complex. And it's going to be a complete different topic. So it's completely a different one.
Anyone else? Any other questions?
Okay, so there was another question asking why we are talking about Docker and whether there are anything else that we can use. Yes, so Docker is something that the open source community is using and something that was developed with the help of Google. So there are a lot of support on Docker, but if you don't like Docker, the other easiest way is using plain LXC, as I was mentioning on the slides. So Linux containers, that is also something that you can use. But with Linux containers, you might need to do some stuff by your own to make it work. So if you are really a Linux guy, then LXCs might be something for you. But if you are not a Linux guy, then I would say you better go with Docker because of the support and the graphical interfaces that you will have with the Docker. Yeah, what else?
Is there any economically huge difference? Sorry, Thilina, is there any economically huge benefit from using containers versus virtualizations?
Yes. So, okay, as a user, you might not get the benefit directly, but as a service provider, you will be really beneficial with the containers because you will be using less space, less resources when you are hosting containers rather than you are hosting virtual machines. But the same way, if you are using a proper service provider, you will get a discounted rate when you are using containers rather than using VMs. So today, if you check the prices for Amazon Cloud, you will have less prices for containers rather than you getting a complete VPS or something like that. The other thing is, most of the time, these technologies, they are not occasional schemes, so you might not find up-to-date data on degree courses or any academic courses. So for that, if you are really interested, that's best is to go with courses like Amazon. So AWS, they have container courses. So if you are really interested, just better follow that because it's really really useful. And even if you are looking for employment in big companies, having that sort of a certification will be really beneficial. Yeah, anything else?
If there are no further questions, then we can wind off. We have last 2-3 minutes if you want to ask any questions. Hope there are no questions. I think Thilina, can we wind off?
Yeah, so thanks and thank you, Siam and WinSYS, to giving this opportunity to meet few friends, few new faces. Yeah, so if any of you want to contact me, okay, I didn't show my thank you page. Let's see, where is that? If any of you want to put an email or something to me, this is my email, and so yeah, thank you, and yeah, hope you do something useful with this, whatever the new knowledge that you got today.
Okay.
Thanks again.
We need to thank you, Thilina. This is because it's a different area where mostly you won't be able to find any classes in Sri Lanka. So thanks for coming up with this topic and to give, because there are more network administrators, the system engineers are there. There are students studying cybersecurity and those things. I mean, for them it is really important, because if they are working on a real environment, the organization must look into the cost-effective ways of maintaining their infrastructure. So this might be one of the easiest way, as you mentioned, that virtualization is much a bit expensive than the containers. So container prices are easy, lower prices. That's one. Maybe even the development, if any, what we're working with the development companies, it will be much more easier for them to deploy their developments, rather shifting for the multiple virtual VMs, and they can run it on one container, and everyone can work around, because instead of working from home, mostly people might be working on a single location. So this might be very helpful for them. Thank you very much, Thilina, because you have started the training even from the very basic, how the data center VM works and the different virtualization environments, and then the Docker. So rather directly going to the Docker and to give an explanation, most of the students, I believe that they will be getting much knowledge in this area. Thank you very much for all the way, when you came on a vacation, but spending time. Hope we can come up with some new topics which on your research what you are doing at 5G. So would like to know some about your 5G, if you can share some of your current research. I don't know whether it's okay to review, but
actually, yeah. So it should be fine. So actually, what I do is I'm researching on the edge computing. So edge computing is where you do some sort of distributed computing rather than decentralized computing. So in cloud environment, what we do is decentralized computing. But in edge computing, what happens is there is the cloud layer, but between the cloud and the user, you will have a edge layer which is like really near to the user. So that for the connectivity part, what we are doing is like if you are the user, you will have a 5G connection with you and the edge computers, edge computing layer. And so today it's still a kind of a buzzword, kind of something that only researchers uses, but in few years time, all the vehicle networks like automated vehicles, then different types of telemedicine, different types of virtual gaming, augmented reality stuff, they will be using edge computing in like 2-3 years time. So definitely you'll be using 5G, and I hope by that time Sri Lanka will have proper 5G, not like the word on a website. So yeah, so that's what we are doing. So for this edge, containers will be the key component that will be running these applications on the edge. So that's why we are more concentrated on containers.
Thanks, Thilina. Thanks for the update. I believe really, Thilina, that Sri Lanka is one of the best country in South Asia who adopted the 2G first, 3G first, 4G first, and hope that we will be adopting the 5G as well. So hope to see your research results can be implemented in Sri Lanka very faster than the other South Asian countries. Yeah. And thank you very much, students, that you attended the program. Thanks, Thilina. Thank you very much. Have a safe journey. Hope to see you on another program. So we'll arrange. So hopefully you'll be able to contribute from Norway. All the best. Thanks, Thilina. Thank you very much.
Thank you. Bye-bye.